Mabuhay Indonesia! Good day to all the viewers. Haribay untuk semua permisa. Assalamualaikum. I'm Romeo Pajigal with my co-partner Dr. Vicente Salvador E. Montaño, and we are from the University of Mindanao, Philippines. The title of our research paper, Using Sunspots to Forecast Crude Oil Prices, a VAR machine learning approach. So, why does crude oil price matter so much to the world? With oil's high demand in the global market comes the possibility that major fluctuations in price can have a significant economic impact as it adds to the cost of doing business that is ultimately passed on to us, and our lives and our families, the entire world are greatly affected. To start with my presentation, the summary, this study applies the vector autoregression model, which is to predict crude oil prices and use sunspot activities. The study utilizes key metrics such as root mean squared error, mean absolute percentage error, and coefficient of determination. And these three minimize predicting errors, provide accurate results, and very effective in generating future data. We also applied models which help scrutinize the proficiency and accurately reveal using the Durbin-Watson, Harvey-LM tests, and the prediction of change in direction in predicting changes in crude oil prices. Results of our study emphasize the reverse relationship. Indeed, sunspot activities remain primarily independent. This is our exogenous variable. Thus, it positively influenced crude oil prices, our endogenous variable or the dependent variable. Findings of our study hold valuable significance among policymakers or government regulators, individual or institutional investors, and even energy market stakeholders. Thus, the result highlights the connections between solar activity, climate variables, and the complexities of energy market dynamics in the interconnected world. For the introduction, crude oil prices are being influenced by geopolitical tensions, such as political instability, military conflicts between countries. We've experienced war up to now, terrorist threats, and for the supply chain disruptions, what disrupted supply chain? Which can cause significant financial losses. Of course, best example of this is the natural disasters we are encountering, such as flood, earthquake, hurricane, and these affect the production, sales, and even the distribution of product and services. Shifting demand patterns is something to do with the law on supply and demand. The inflation data, the Federal Reserve rate cuts, the Brent crude price, which sharply increases, and the geopolitical stability. Also, we discussed the hybrid models like the ensemble empirical model decomposition, such as the ARIMA and the FFNN, which are promising, yes, but still needs improvement in enhancing forecasting performance and also in simplifying the model. The economist Irving Fisher, I know you know him, the one who created the Fisher effect, which describes the relationship between inflation and interest rates. He even theorized that fewer sunspots cause severe winters, affecting agriculture, food prices, and economic repercussions. There are also limitations and criticisms of using sunspots for forecasting in our research. There are inconsistencies. And also, the sunspot cycle cannot forecast price changes attributed to other factors such as wars, natural disasters, and geopolitical tensions I've discussed earlier. For the methodology, under the research design, we used vector autoregressive models and integrating machine learning techniques. Also, we apply model specifications. We do estimations and even validations in forecasting accuracy. Also, we apply statistical tests to measure the reliability and validity of the data output result. For the data collection method, sunspot activities were being gathered from the Solar Influences Data Analysis Center. On the other hand, crude oil prices were being reported in the Index Mondi from February 1994 to May 2023. We even applied the quantitative technique in forecasting like the time series. So it was suited for analysis using the VAR model and machine learning. For the data analysis method, first, the stationary check using the augmented Dickey Fuller. So this is a test being used to see if a time series is stationary, meaning not moving, using the variables in our study. And then after that, the machine learning techniques with the VAR model were being employed to enhance forecast accuracy. It follows the data were being divided into 3, training, validation, and test sets. And then after that, the VAR model is being estimated using the OLS, or the ordinary least squares, which is best known for regression techniques. It provides a global model of the variable or process we are trying to understand or predict in this study. And then finally, the application of econometric model or formula for the VAR for both the in-sample and out-of-sample data. For the results and discussion, of course, I will make an interpretation and analysis of the data as provided by the tables because of time constraint. Okay, so table 1 here shows that the lag sunspots and lag crude are non-stationary. The p-value is also greater than 0.1, which confirms this result. The first differencing resulted in the tau statistic and the tau critical value, which indicates that sunspots and crude data were stationary. Indeed, the p-value is less than 0.01, which confirms also the result. For the interpretation of the ADF test result, it implies that taking the first difference between lag sunspots and lag crude removes their non-stationarity and makes them suitable for further analysis. For table 2, this means a co-integrating relationship exists between the two variables we are using, and that the p-value of less than 0.01 also confirms the result. Further, the result implies that sunspots and crude oil move together and that changes in sunspots may impact crude oil prices in the long run. For table 3, the BIC criterion is more likely to select a smaller model than the AIC criterion. By the way, BIC stands for the Bayesian Information Criterion, and the AIC is Akaike Information Criterion. And that the result this implied that the choice of model was based on the most miniature models possible. Thus, the model with 2 lags was being chosen. And then for table 4, the VAR machine learning output results show that the model is a perfect fit and performance for both in-sample and out-of-sample data. The RMSE, MSE, and MAPI indicates that the model has a minimal prediction error and high accuracy. This would reveal further in the results stated herein from A to F. For table 5, the Koleski decomposition of the error covariance matrix and the impulse response functions has a 0 restrictions. Indeed, the VAR model assumes that sunspot activities are independent of crude oil prices, and also it shows that sunspot activities have a positive and significant effect on crude oil prices. For our conclusion, the supervised machine learning method confirmed the relationship between the number of sunspots and crude oil prices. Also, it is critical to highlight that predicting crude oil prices is highly complex, and that this study has academic and practical implications in energy economics and financial forecasting. And there is an improvement in the accuracy and the reliability of the forecast. And the reliance on sunspot data as a predictor for crude oil prices is complex and multifaceted nature of crude oil prices determinants. A sunspot is an astronomical event that may not directly influence market dynamics. And that ends my report. Thank you for listening.